What is transition metal? Transition metals are metallic elements that occupy the d block, with each group 3 to group 12 of the periodic table and have d electrons in the valence shell. According to the website of Corrosionpedia 2020, the general properties of transition metal exhibit multiple oxidation states: high melting point and boiling point, high density, color compound, and catalytic properties. Advanced materials are materials that are specifically engineered to optimize the cost and the efficiency of existing technology products that are innovated as the advanced materials affect all industry, especially in heavy industry. These advanced materials also create new products and performance of existing products and materials to optimize. Sahih 2021. The main components in producing advanced materials such as superalloys, high-strength steel, and magnetic materials are transition metals that specialize processing and synthesis technology.
Superalloys are composed of elements discovered over a long period of the transition metals. They are composed of various combinations of nickel, iron, cobalt, and chromium, as well as tiny amounts of tungsten, molybdenum, tantalum, niobium, titanium, aluminium, rhenium, ruthenium, carbon, and boron. The three primary types of superalloy are nickel, iron, and cobalt-based alloys. The nickel-based superalloys are perhaps the most essential and widely used of this alloy when high temperature strength and corrosion or oxidation resistance are needed. Nickel displays the face center cubic FCC crystal structure, and this provides the major advantage of the superalloy: substantial ductility and hardness, which make them highly suitable for engineering application. Moreover, the FCC crystal structure is stable from ambient to melting temperatures. Many of the industrial nickel-based superalloys contain alloying elements, including chromium, aluminium, and titanium, also molybdenum, tungsten, niobium, tantalum, and cobalt. Although an extensive variety of alloying elements are employed, certain broad statements can be made. The majority of the alloying elements are derived from the D1 block of transition metals. Perhaps unsurprisingly, the behavior of each alloying element and its influence on phase stability are highly influenced by its location in the periodic table. The first class of elements includes nickel, cobalt, iron, chromium, ruthenium, molybdenum, rhenium, and tungsten, which prefer to partition into the austenitic and therefore stabilize it. These elements have atomic radii that are quite similar to nickels. A second group of elements, aluminium, titanium, niobium, and tantalum, have greatly larger atomic radii and hence favor the formation of ordered phases such as the compound nickel-3, aluminium, tantalum, titanium, known as boron, carbon, and zirconium, are a third class that tends to separate at the boundaries grains of the phase due to their atomic sizes being substantially different from the nickels. Carbide and boride phases can also be promoted. Chromium, molybdenum, tungsten, niobium, tantalum, and titanium are particularly strong carbide formers. Chromium and molybdenum also encourage the formation of borides. All superalloy like nickel have a face-centered cubic FCC crystal structure and consequently 4 atoms per unit cell. This crystal structure is stable from room temperature until melting temperature, which for pure nickel is 1455 degrees Celsius. This provides an effective upper limit on the superalloys used for service at high temperature.
According to website of Chemistry Laboratories in 2015, magnetic materials are materials that have a magnetic domain and are attracted to an external magnetic field, as these materials are strongly attracted by a magnet. This is because of the electron configuration and the size of atoms of transition metals. The electron spin and number of unpaired electrons in the specific compound indicates the magnetism of the compound, as the spin of a single electron is denoted by the quantum number m as positive half or negative half. When the electrons are paired, the magnetic field is weak compared to unpaired electrons, as the unpaired electrons make those transition metals magnetic. Due to the repulsive forces between electrons in the ligand and in the compounds, the electron configuration of a transition metal changes in a coordination compound. Cited from website by Madhu in 2018, the magnetic materials are divided into several groups, and one of them is ferromagnetic, which is commonly used in daily life. Ferromagnetism is the basic mechanism and permanent magnetism that is associated mainly with nickel, iron, and cobalt, and has permanent magnetic dipole moment as they tend to align parallel with each other and make up domains. Ferromagnetic, or the formula is Fe3O4, is an inverse cubic spinel compound where ions are shared between tetrahedral and octahedral site, whereas tetrahedral site being occupied by Fe3 plus ion and octahedral sites by both Fe3 plus and Fe2 plus ions in the cell ratio. This is I quote from Prakash in 2007.
High-strength steel (HSS) is steel with a yield strength greater than 200 MPa and a yield stress grade ranging from 460 MPa to 990 MPa. High-strength steels, as the name implies, provide higher strength and durability. This makes them suitable for usage in a wide range of industries, from construction to automotive manufacture. High-strength steels are low to medium alloy content steels with excellent strength and hardness, as well as good for mobility and weldability. Despite their great strength levels, they also have unusual low temperature notch toughness and fracture propagation resistance. This one-of-a-kind mix of qualities is the result of careful selection of both chemical composition and heat treatment. Nickel, manganese, chromium, copper, and molybdenum are the main alloying elements in modern HSS, with boron usually 0.02% boron providing the additional hardness. These components are frequently used in combination, hence, HSS can be categorized as multiple low-medium alloy heat-treated steels. Most HSS also contain one or more micro-alloying elements such as aluminum, niobium, titanium, vanadium, or zirconium. Vanadium-bearing steels should be avoided if post-weld heat treatment are to be used due to the risk of deleterious effect on heat-affected zone, exact notch toughness. Specific composition ranges for each element are changed by the steel manufacturer according to the strength and other property needs, as well as to provide the required hardenability to the extent that steel specifications allow. Higher alloy concentration are necessary in thicker plates to compensate for the cooling rate retardation that consistently occurs when heavier plate components are quenched.
Pros for the having transition metals in developing of the advanced materials is the efficiency is high and cost is low. So the production of advanced materials such as alloys or high strength metal can be produced in a big number. Next is it's easy to manufacture with a great uniformity. And lastly is transition metals is sufficient stability and does not react easily, not like group 1 metal that easily react with the oxygen and water. The cons of having transition metals in for developing the advanced materials is there are some of transition metals are restricted availability. For example, palladium. Next is some of the transition metal also sell at a very high price since it's a very rare and very hard to find, such as rhodium. And lastly, they also some not all transition metals are safe, and some of them are having a high level of toxicity.
As the conclusion, the transition metals truly important in science industry, especially in developing the advanced materials such as superalloy, magnetic materials, and high-strength steels. Those materials truly is humans' life and developing our country. Although those creation helps a lot, but there are pros and cons of the transition elements, such as the pros, it low cost, easy to manufacture, and sufficient stability. For the cons, there are some of the elements that are restricted availability and higher price, as it is rare and also toxic and may harmful towards human. Those transition elements must be used wisely to avoid any harm and deadly events. Thank you.